No, I am ready. I was waiting.
Luca, the floor is yours.
Okay, so good morning or good afternoon or good evening to everybody. Thank you for inviting me here. I will talk about the use of artificial perception for community protection, which is the main field of activity of Genesis, which is a company which was incorporated in 2007 after an experience after graduating in Parma University, and then 2 working experience in Philips and Marconi, and then a PhD at Scuola Superiore Sant'Anna. After the PhD, with other 5 or let's say 4 friends, I opened the company, and it took the first more or less 5 years for the company to build what I call the tools are, meaning through research and development projects, the technical development, patents and validation and so on. We developed our 3 main pillars, which are a wireless sensor network platform, machine vision, and an applied AI engine, with which in 2013 we started selling our AI-enabled perceptive devices. Let's say a few months ago, we entered the Camlin Group, which is a larger company based in the UK, which is very similar to Genesis in what refers or concerns innovation and research, but it's larger, and it's much larger, and then we started a new adventure just a few months ago. And this is still a small company. We were 12 a few months ago. Now we are nearly 18, and the plans are to get 40, 50 people in 2 years from now. Nearly all of us are engineers. 40% now as a PhD, and it is still a very young company, as 90% of us is less than 35 years. We are very active in the research environment and innovation, and we got the honor of being selected by Massachusetts Institute of Technology in being amongst the 5 most innovative companies in Italy. 3 headquarters. One, the main, is in Parma, then in Lisbon in the UK, and another office in Boston. The mission of Genesis is to address the community protection through the development of intelligent perceptive devices and systems, which are at the interface between humans, machines, structures, environment, which are able to understand the situation in which they are and make predictions. This is the pyramid, let's say, of the information, which starts from sensing. Then here AI starts entering the game, so recognizing behaviors, understanding situation for making prediction. And this picture highlights all our philosophy. So I don't know if you can see the pointer, but from raw data, we go to information. From sensing, which is data acquisition from environment, we go to perception. And from chaos, we go to complexity managed, using often a sort of what is called normally a bio-inspired approach, which in this picture is represented by the fly of this bird, and because our main source of inspiration is nature and the solutions that are found in nature to solve the complex ill-posed problems. And the name Genesis comes from the conjunction of Henon, which is a mathematician of chaos, and Synesis, which is the Greek word which stands for holistic approach to a problem, or taking into consideration all possible angles when facing with something unknown or a new situation. So Genesis masters the whole chain of information, from data acquisition to data transport, processing, when we apply models and to the data we acquired, to make a prediction. Then, so we start from the real world, then we migrate to the digital world, and we get back to the real world through the feedback, or to give feedback to the users through web apps or API. The data collection can come either from low complexity devices which can be spread on the environment, or higher complexity devices which, for instance, take as input audio, video streams, and so on. What we do are perceptive internet, let's say the main business is perceptive internet of, or now Internet of Services or Internet of Everything for human environment machine interfaces. The business areas, main business areas are environment, industry, mobility, health and wellness, and security. Not all of them we achieve at the same level, but what is common amongst these areas are the four platforms that we use. The most important one being the artificial intelligence platform that we developed, Whisper, the wireless sensor network platform that we conceived and developed because we couldn't find on the commercial environment something which could fit all our needs, and then we will go a little bit deeper in this. What we call PIEs, Perceptual Intensive Embedded Systems, and PANTOBOT, which is an automatic pantograph inspection system for trains. Starting from the first, so artificial intelligence platform for perception. So we go back to what was said a little bit earlier. What is perception from an operative point of view? So we can call the collecting of sensorial input from sensor. We call perceiving the matching between sensed and expected inputs, and we call understanding the ability of the system to make successful prediction. A theoretical and mathematical framework was introduced recently to, let's say, cover these aspects, which is called the memory prediction framework, which was introduced by Hawkins from Palm OS and now from Momenta, but which was initially implemented in what are called hierarchical temporal memories. We gave our own full implementation of this framework in what we call Hennessy's memory prediction framework. Very, very briefly, this is a Bayesian deep learning network which specializes on spatial and temporal patterns, and which builds a distributed memory of the scene, of the situation in which the system is exposed on the hierarchy. On the nodes, so distributing it among the nodes. We focused on a multidimensional time series, on continuous learning. We implemented this feature because it's needed in real world cases. And what flows from level to level are not data, but a probability density function. So we move in a transformed domain from the beginning, so from the physical signals to the probability distribution. We developed original implementation of the nodes and the architecture, which is agnostic, so work with the many implementation of this node. So from the bottom we have sensory data which enters. We have a high-level classification which is done at top level with understanding of the situation, and then what flows back are expected sensory data which can be compared with the real sensory data which enter time by time. Whenever there is a correspondence between this top-down and bottom-up flow, this means that the network has understood the situation, and we can ask the network to make predictions in future. Now let's go straight to what are the applications to which we apply not only this but all other skills of Hennessy's, which are the machine vision and the wireless sensor network. And these are different cases, different sectors: land, environment, structure, mobility, and the smart city. What is common is the flow of information. First step, data collection. Second step, advanced processing. Third step, the prediction. This is the wireless sensor network that we developed in Hennessy's. The main features are automatic update of the firmware over the air, self-healing, self-setup, long node autonomy, completely automatic setup of the network, and the fact that every acquired data is time-stamped with precision. As our AI tool and our AI, let's say, philosophy strictly bases itself upon the time, let's say, labeling of data, of events, it's important that our network allows us to give this timestamp, precise timestamp, even when the node is temporarily not under connection or isolated. The network was used in several real-world scenario. This is one, a landslide, which was monitored with our network, and legacy sensors, which we made a networked sensor adding our electronics. And this is a snapshot of the web interface that we provided the customer with. So fusing video data extracted from sensors, data extracted from meter station and accelerometers. But again, here intelligence comes because this is not the definition of artificial intelligence. This is just, if you want, image processing that helps, but then there's a level of intelligence in order to clean the data, in order to extract relevant information. This is a less sensor. It's an extensometer, which stops working when the landslide moves too much because the cable reaches its limit, and this is unacceptable. So we implemented virtual access based on machine vision and 3D mapping of 2D images in order to have a set of sensors which doesn't break when it's more needed. While in this step, we applied our AI tool to analyze data, historical data extracted from sensors which are monitoring a big landslide in order to understand what is the behavior of this landslide, and then make prediction on what will be the behavior of the landslide depending on real or forecasted weather conditions. This is a sensor that we developed and patented here in Enersys. It's an intelligent crack meter. Its main feature is the combination of a crack meter, contactless crack meter, with an accelerometer, which is able to detect and measure vibrations and oscillations in 3D. So if this is combined, our synchronized work, we can have a distributed sensing system, and which gives us data which can be processed by our AI because they are referenced with precision in space and time. This is a recent case studies of this network. This is a village, the hills, which was built on a landslide and besides a railway, so it's moving. So we distributed our digital sensors on the village, and we analyzed the results. This is another system that we developed and installed to protect a bridge over where railway is running. And this is a mountain, very peculiar mountain. This is a national park, which we are monitoring with our BISPER network in order to get a model of the mountain itself, fusing vision and in situ monitoring. This is the software that we developed for automatic inspection of pantograph. Here, AI is used to recognize the pantograph model, identify the areas of interest, identify outliers, study them, and speed up the process of analysis. This system by the National Railway Company here in Italy, and we are selling this in Italy and abroad. Another concrete application of and AI. This is the third platform, which is the fusion of vision and acoustics. This is an array of 64 microphones, MEMS microphones, with a central camera, and we can combine two input channels, making the system synthesize any number of virtual directional microphones depending on what the input or depending on what the content of the vision of the scene is, processes the video and tells the audio system where to virtualize or to direct the microphones. And of course it can work also in the opposite direction, so making the sound direct some video analytics restricted in some region of interest. Next step for us is to port this AI tool, which was developed in 6 years of collaboration of research with Toyota, and which is covered by 2 international patents, from to embedded systems. And partner of a European project which is called ARP, and in this we are taking HMPF and getting to mobile processors. Next step is the wearable AI, meaning that this core is expected to work, and we proved it already, on a real world real-time signals, for instance, a wireless body area. The same AI tool was used also to process big data, so to find, store, and to record positions in space and time between or among the data collected from social networks or from the interaction of the users with our apps. And the product in this case is an artificial intelligence-powered recommender system to deliver and so on. So to summarize, this is the information pyramid, and this cover all the parts from data acquisition from simple devices, data acquisition from more complex devices with local processing, because I told you that the processing is going to become local in order to maintain a hierarchy, in order to be scalable and resilient. And we cover also the feedback through our KaiGi platform, which is this recommender system for smartphone. Next step from research to market. So we are inserting artificial intelligence in the wireless sensor network platform, as I showed you. We are putting the prototypes developed in the framework of a European project, which is over now in the EEG analysis to the next step through introduction, thanks to the introduction of artificial intelligence in the field of brain-computer interfaces. And longer-term research is something which I didn't describe now, maybe more distant from AI, but this is not entirely true, you will see, because AI can enter, of course, in prosthetics, and this goes back to my activity also in Sant'Anna, and will be active in the field of Internet of Touch very, very shortly. Good news that we are hiring, and active projects for which we are actively searching people are advanced human-machine interfaces, mainly touch-based and EEG-based, medical, biosensor, advanced prosthetics, wireless sensor network and electronics. We're searching for experts in protocols and hardware design for new nodes, and software, web apps. The 3 main. So this is also these positions are on our website, but I take a couple of minutes to highlight them here. So we are seeing really outstanding engineers and inventors. Enthusiasm is the second most important characteristics, and flexibility, because even if we are growing a little bit, we will maintain the spirit of a startup, and a mixture of a startup and a research, an industrial research center. We are interested in both junior and senior, with and without PhD, internship, and open positions. And these are the topics. So for the open position, brain-machine interface, embedded machine vision algorithms, and the others that I already introduced a few minutes ago. Good news is that now we have got, or we are going to have space, because now we are in 120 square meters, and the situation is like the one that you see in the picture on the left, bottom left. This is the new office where we will enter in January. This is a beautiful villa which will be all for us. We have space also to grow and to hire, to host students, internship, and new employees. So I managed to stay within the 20 minutes. These are addresses to get in touch with me or to apply online. And now I leave the stage to questions. Thank you.
Okay, thank you. So, any questions? Because if I can make a short comment, I think we have an example here of the benefits of thinking deep and thinking bold. You know? So, I mean, this kind of biomimetic, bio-inspired approach is actually, so now we see that it works, but a few years ago, probably was more of an enthusiasm. Maybe, Luca, you may comment briefly on this, how you felt at the beginning. Because now, more or less, you know that it works.
Yeah. Yes. At the beginning.
How you felt at the beginning? So the very how small was the very beginning?
So when I started, or let's say this, I started Genesis with this vision in 2006 with a friend of mine, which was in the lab. We wanted to work together because we shared this vision, we shared these ideas. We were not allowed to do that, so we started Genesis at night. Around a table in a bar, that was the idea, and we started working in our spare time. So it was from morning to evening in the lab, and then from evening to very late in the night for Genesis. Then we split because this friend went to US to live, so we took advantage of this time lapse, or let's say time zone, for working together. But after 1 year, we discovered that with that size, we would never been able to take important projects or to do big stuff. So the idea for me, okay, let's resign, let's open Genesis full time. We changed and Genesis became a real limited responsibility company. With this passion and this vision. So at the beginning, we managed to win a competition with Toyota, which decided to give me an opportunity, even if I left the university. So we applied with a new proposal, and we got the project. So our first customer was Toyota. So I can say that if Genesis managed to live and to grow, it's thanks to them, which gave us confidence, and because we made from the beginning the choice of not living as a spin-off on the shoulders of the university. So we didn't have any project with the university, any consultancy, anything of that. We said we need to start with a customer. If we manage to live, okay. If not, we close anything else. And then from Toyota, we decided that it was too dangerous to stay. So we started developing our own platforms, which are the wireless sensor network and the rest. We started trying to diversify the product while keeping the red rope, let's say the long-term vision. And now, after several years in which we asked ourselves, are we right? Did we take something for granted which is wrong, and so on and so forth? Now we know that it works, it can work. And we got the proof. So.
Okay, nice. Also for sharing the beginnings.
Yep.
Okay, I don't know if you have other questions. So if you have a question or comment from the audience. No, okay. A final remark is that so if you are looking for a very cool place where to work, maybe also in a very nice Italian villa, there are many people seeing it as a tourist destination. So if you want to do with some kind of very, very high-level AI tourism, I don't know, forgive me,
You're welcome.
you may probably consider this opportunity. Okay, thank you again.
Thank you too.